learn about some rules regarding circuits. Okay, now these rules, according to the textbook, they are in the third chapter. Okay, according to the textbook, they are in the third chapter, but we need them now. Okay, so we will cover it right now. Obviously, we will not repeat it. It's the third chapter. All right. Okay, so these are known as Kirchhoff's laws or rules. There are two, right? These are known as Kirchhoff's laws or Kirchhoff's rules. Okay. To be very frank, these are common sense. Okay, એના માટે કોઈને આટલું બધું રેકોગ્નિશન આપવું તમને એવું થશે લે આવું તો અમને આવડે છે. Okay, really, not kidding. It's that simple. So let's start with the first one. Okay, so that's called Kirchhoff's current law, KCL. Kirchhoff's current law. I know you might not be knowing very too or perfectly about current, but that's okay. Just the basic information that you have from 10th standard will do. Right? Common sense, like I said, absolutely common sense. Right? So suppose there is some wire. Okay, let's say. Right? Okay, and current is flowing. Some charge is flowing. Current means flow of charge. Yes or no? Yes. Right? Okay, you know that. So suppose here there are two branches. So obviously when current will come here, it should split. Yes or no? Yes. Just like water in a pipe. If some water comes here, what will happen? Some will go here, some will go there. Yes or no? Yes. Sure. Yes. So the law is that if this is, let's say, I1 and this is, let's say, I2 and this is, let's say, I3, then the Kirchhoff's current law is as follows. The sum of currents incoming at a junction is equal to the sum of currents outgoing or leaving. Outgoing means leaving the junction. Okay, first the common sense part. Can you know what coming in? Suppose 6 goes this way, then how much will go the other way? 4. Common sense is that? Sure, it's just that 10 is coming in, then if 6 goes out here, then remaining 4 has to go out on that side. Yes or no? Sure. I to check. Clear or not clear? Clear or not clear? Yes. Sure. Yes. Okay, everyone got this? So if this is a junction, what meaning of a junction? A point where there are branches. Okay, maybe more also, but there are definitely branches. So this is a junction. So if I1 is coming in, it's called incoming. I2 is going out, I3 is going out. There. Is that okay or not okay? Sure. Fine. So you can write this actually also as, symbolically, sigma I incoming equal to sigma I outgoing. Okay, sigma I incoming or sigma I outgoing. In your textbook, it is not written in this form. But meaning change. The words used are different. At that time, I'll just make you read it from the book and topic complete. Is that clear? Right? Let's just try a couple of simple examples. Suppose it's like this. If I tell you that, unit of current is ampere, yes or no? Yes. 1 ampere current comes in this way. Okay. And 2 ampere current comes in this way. Then you have to tell me in the remaining, the third part, how much will be the current and in which direction? 3 ampere. Yes or no? Yes. Outwards or upwards. Clear or not? Yes. Sure. Everyone understood that? Yes. 3 ampere and going out or up. Clear? Yes. Fine. Let's try it with more. Right? Suppose it's like this. then in the remaining part, in the one remaining portion, what will be the current? Raise your hand. Come on. એકદમ easy છે. એરો તો બધા પર દેખાય જ ને બધાને. એમાં પ્રોબ્લેમ છે. ચાલો. How much will be the current in that one remaining portion? The right side એમાં મેં નથી indicate કર્યું. જય 2 ampere coming inwards. Who agrees with him? Who disagrees? તો શું આવે તો શું કામ જોઈને આ બોલો ખબર બી ઓનેસ્ટ વિથ યોરસેલ્ફ નો ખબર પડી હોય તો બરાબર ખબર પડી હોય તો ટાઈમ પાસ નહીં કરવાનો બરાબર ને sit down there. Let's see how. What does this tell you? આને તમે પાઇપ ના ફોર્મમાં વિચારો તરત આવડી જાય. 1 liter water is flowing this way. From here 2 liter water is coming in. પછી અહીંયા 5 liter જાય છે ને તો આવે છે તો 3 5 જાય કેવી રીતે? So it means in the remaining here 2 liter should be coming in. Yes or no? Yes or no everyone? What 5 9 है? If 5 is not coming in, how can 5 go out? પાણી ક્યાંથી પાઇપમાંથી બને છે? Wonderful source of water, isn't it? Yes or no?
Yes.
Okay, so this is actually law of conservation of water, correct or not? Okay, how to solve these kind of things when you are confused or anything? You don't know the direction also. No problem. You can assume any direction, but the maths will take care. Suppose you assume wrongly outside x. So खाली यार rule use कर दो. Okay, I hope you have written this rule.
Yes.
Okay, if you use that rule, 1 incoming, 2 incoming, 5 and how much x outgoing. Did you understand? Yes or no?
Yes.
Again, sigma incoming is equal to sigma outgoing. Got it? How much is sigma incoming? 1 and 2. Outgoing 5 and x. So how much is the value x? Minus 2. Is that okay? Minus 2. What does that minus sign mean? You took it that way, but that means the direction is wrong. It's actually inwards. Did you understand? Towards the junction. Clear or not clear?
Yes.
Fine. Not too simple. Got it? So suppose by mistake you even assume the wrong direction, then also maths is your friend. Right? It will show you that no, the direction is not clear.
Yes.
You can use this in any case. Fine. Now why does this happen first of all? It says it's like this, but why does it happen? You can't say common sense. Right? There has to be a reason. The reason is law of conservation of charge. The reason is law of conservation of charge. If you think of it in form of charge, it will be perfect. See, if some charge comes in from here, charge can neither be created nor be destroyed. Okay, and this one, if it does not store charge, generally wires cannot store charges. Okay, capacitor can store charge, wire cannot store charge. So what happens is whatever current comes here, whatever charge comes here, it has to split and either go here or here. Did you understand?
Yes.
So basically we should have Q1 equal to Q2 plus Q3. Yes or no?
Yes.
Did you understand? And that's why when you divide this by time, charge by time, charge by time, charge by time. Charge upon time, current. Clear, simple version. Okay, detailed, sorry. Maybe I say so, but I'm not. So charge upon time will give current. So you get this relation. Did you understand? Sure. So Kirchhoff's current law or current rule, also called first rule sometimes, is due to what? Is due to which law of nature? Law of conservation of charge. Is that clear? I'm giving you just 30 seconds to write down note whatever is on the board if you have not done it yet. Okay? So we get Q1 equal to Q2 by Q2 plus Q3 and then we can divide it by some time and that will give you current. Okay? Again, this is a simplistic explanation but it works. There is nothing wrong with this explanation. Fine. But to common sense cannot do. Think about it. No. Current is not lost in the form of heat, but it is that when current will pass, energy will be lost in the form of heat. And as current passes, current does not decrease. For example, you have got a wire. Suppose here the current is 1 ampere. So यहाँ आगे जैसे तो यहाँ 0.1 ampere नहीं दिया. Did you understand? On the same wire the current will remain the same. Okay. Actually it has got something to do with series if you think about it. Right? But yeah, more details will definitely come in the next chapter where you will understand properly why current cannot decrease. Right? So that's why the values won't decrease. Okay. Well then. So this is the first rule. Okay. So like I said, we can use the first rule not just for current like that, but similarly it is also applicable to charges, that if charge Q1 flows in, charge Q2 goes out, Q3 goes out, then Q1 will be equal to Q2 plus Q3 like that. Did you understand? Sure. Amazing. Next now, so now the second one is called KVM. That's for voltage. Second rule. It's of second rule. Okay, it is for voltage. Now this is slightly more detailed. That is, we will have to go into a few more things, right? It's that if we move around a loop, the sum of potential differences or voltages is 0. If we move around a loop, the sum of potential differences or voltages is 0. First of all, I'll try to explain it by intuition. Then we'll go to a little bit of physics or math. See, if I tell you that you are at some place A, okay, and you walk around, okay, assuming there's land everywhere, you can walk wherever you want. Okay, suppose I start walking from here, and I walk up there, then I go over there, and loiter around in the lobby for a while, and then I come back. Okay, probably I went downstairs as well, and then I came back, and now I'm standing here again. Okay, then I'm standing at some level, yes or no? Then what was the initial height at which I was standing? It was this. What's the final height at which I am standing? Same. What's the total difference of? What's the total difference of height when I moved here, everywhere, and then came back to the same point? What's the total difference of height? 0. Lost. Doesn't it look like common sense? The same as what is different? How can it change? Right? But basically this is happening because of conservative nature of electric force. Right? Because of conservative nature. It's there. Now the property. Delta V. Delta V means voltage, isn't it? Okay. If you go around a loop and you find out potential differences. So starting point, ending point, both are same. That's a conservative behavior. If you go around a loop and come back to the same point, the work done will be 0. The change in potential energy will be 0. Change in potential will also be 0. Did you understand? Yes or no? Yes. Right? So you can say that this second law or second rule, is either you could say it's because electric field is conservative. You could say either it's because electric field is conservative, or if you want to give another reason, you can say that this is due to law of conservation of energy, because obviously if electric field is conservative, it will conserve energy. Did you understand? Friction also to that. So energy changes. I hope you like that. If you take the chair over here and you move it there, and then you move it back, energy hike. Yes or no? Yes. Right? You don't get the same energy back. Clear or not? Fine. So this is the non-conservative behavior of friction. आम जाओ तो एक energy ले ले, आम जाओ तो ले, पाची ना पे. Gravity is not like that. ऊपर ले जाओ तो energy ले ले. નીચે લાવો તો એનર્જી પાછી આવશે. Yes or no? Yes. So that's what we have. Right? So this is due to conservation of energy. Now what does this mean for us? How can we use this rule? Okay. Let me draw a circle and explain it using that. So let me just mark this here. If while moving in a loop we go from lower potential to higher potential. તમે પડે ને શોર્ટ ફોર્મ માં મિત્ર આખું લખી દો low potential to high potential. Then that would mean the potential difference is plus V. Yes or no? Yes or no? See this વાત છે ને, if I went from lower to higher, the potential difference higher minus lower, positive or negative? Positive. Yes or no? Yes. Sure, got it? Right? Actually plus V no લખો તો ખાલી positive એવું લખો. Okay. And if you go from higher potential to lower potential, then negative. Are you guys absolutely sure? Okay. So what is this telling you is that if you go around the loop and come back to the same point, if you go around the loop and loop obviously means coming back to the same point, right? Okay. એના માટે clarification જોતું હોય તો અહીંયા closed લખી નાખો. Closed નો meaning શું થાય? Coming back to the same point, right? Closed loop. Okay, then the sum of all the potential differences is 0. Let's use it in a little bit, in a very small circuit which has capacitors. For example, what will we find? We will not find anything new. Already out in there. Right? But these are just like formal statements that help us understand things better or to use them easily. So suppose these are variable pairs. Let's say here's the loop. This point is A, this point is B, this point is D, this point is E, and this point is F. So I have decided that I'm going to move across the loop in this pattern. Am I coming back to the same point? Yes. A, B, D, E, F, A. Clear? So the next equal to chapter 3 mark. I'm investing time. Is that okay? I hope I'll get return. So A, B, D, E, F, A. So if I start from here. Now, we know that this is 12 volt, right? This is first capacitor, second capacitor. Okay, so this plate will be positive, that plate will be negative. This plate will be positive, that plate will be negative. Okay or not? Yes. So if I start going from A to B. So when I go from A to B, I am crossing what? A capacitor. Yes or no? Yes. But we are going from LP to HP or HP to LP? HP to LP. HP to LP. Who understands? Higher potential to lower. Why can you say, or how can you say that? Because we went from the positive to the negative. Did you understand? In a capacitor, positive plate is at higher potential and negative plate is at lower potential. Yes or no? Yes. Sure, no doubt about that. So here look to minus negative V1. Why V1? Because first capacitor. And why minus this rule? Simple rule. Final minus initial able current. So if you go from A to B, then B is on the negative side, A is on the positive side. That's why minus V1. Understood? Now let's go from B to D. Who can tell me what I should write? If we go from B to D, you try to suggest what I should write. If we go from B to D, same as current, second capacitor is there. Right. D 0. B to D. Minus V2. Who agrees with him? Who understands what he's saying? Yeah, sit up. Well done. Let me still clarify it. So we are going from the positive. Positive is it? What about negative? So from positive to negative means we are going once again from high potential to low potential. Clear or not? That means we should write negative. Negative what? V2, the voltage of this capacitor. Did you understand? Yes or no? Yes. Sure. Okay. D to E. D to E 0. Guys, is that okay? Or you can say, see, we are actually adding potential differences. Look at this. Between D and E, there is no potential difference. Is that clear?
Yes.
Sure?
Yes.
Why? Because they are on the same wire. Because they are on the same wire. That's why no potential difference. Okay, then E to F. So when you go from E to F, you are going from the negative terminal of the battery to the positive. Means you are going from lower potential to higher potential. What should I write? Plus V. V means 12. Or plus V. Chalo V laghe. Is that clear? V is the battery voltage. If V is the battery voltage, then that will be equal to 0. Why? Because F to A, once again there is nothing. Understood? F to A, once again there is nothing. So when we come back to the initial place, all the addition of differences should give us 0. What is this? What is this? Is that clear? V equal to V1 plus V2. Clear or not?
Yes.
Sure. This is the same thing. Got that? Absolutely clear? Right. Understood how to use the second rule to make something like an equation. To make something like an equation. Clear? Fine. Okay. Right. So of course this is the simplest application. Right? Of course this is the simplest application. Let's take one more. Okay. So these are the two rules. That's it. First rule is due to conservation of charge. Second rule is due to electric field is conservative, or you could say that this is law of conservation of energy, or because of law of conservation of energy. Got that? Clear? Fine. Now, let's understand one thing first. Kirchhoff rules are not necessary. They are not necessary at all. Jo, our relation happen. So basically, Kirchhoff rules can be used to derive everything that we know so far. Everything. Okay, parallel voltage, same voltage, at that, blah blah blah. Everything can be derived using Kirchhoff's law. So they are like general versions. So when to use them? Only use them if nothing else works directly. Only use them if nothing else works. Okay. So important. See, it's similar to, I have told you that if you want to find potential due to a point charge, then you can do it like this. Yes or no?
Yes.
But તમે દર વખતે આવી રીતે કરો તો શું થાય? ખોટું પડે? No. This is not wrong. It's not wrong. It is only long. Exactly there. Using Kirchhoff laws, you can solve any given circuit in the world. Any given circuit. ગમે તે કે current, voltage, charge, etc. They find બધું. Got it? But it's not always the wisest choice. It is not always the wisest choice. Sometimes the method is very long. એના બદલે shortcuts ખબર હોય અમુક shortcuts in the sense properly derived formula like here. We know in series voltage is added. So series block નાખો તો કામ Kirchhoff law કરો. Got it? Or not clear? So that doesn't mean they are useless. There are some situations where however hard you try, બીજે કઈ રીતે થાય છે. However hard you try, you cannot do anything except Kirchhoff's law. Understood? Yes. That's where they become very useful. Okay. Now, I've explained the laws. Let's start with the assignment. Come on. યાદ રહેવું જોઈએ without fail. I can't put enough stars. It's that important. Okay, આવડી જશે તો law use કરતા આવડી જશે. There's no doubt. Okay, let's start. પહેલા 4 or 5 એક question આનો. They can be done without having to worry about Kirchhoff law that all. Okay. Right. Before we start, let's just write one sentence here. Again, this is very important. Suppose you have a battery like this. There's a switch. There is a capacitor. And we have connected with a resistor. થોડુંક તો યાદ છે ને resistor નું કે નથી? બહુ વધારે નહીં આવે, don't worry. 3 equal to IR new. Yes. Okay. So, you know what happens is when you try to turn it on, at that time capacitor will still be getting charged. If you remember, I told you that for a short time charge will flow. Charge flows means there will be current. So, write down two sentences. Okay. Just after closing the switch, capacitor behaves like ideal wire. Ideal wire means allows current to flow very easily, or you could say conductor. Behaves like ideal conductor. Okay, this is one part. The second part of the same thing is a long time, means theoretically infinite. Okay, a long time after closing the switch, capacitor gets fully charged or completely charged. Okay, and behaves as insulator. Okay, once again an ideal insulator. By the way, this last state means what happens after very long. That is called steady state. Steady means after everything settles. After everything settles, nothing will change now. That would happen after a long time. Okay. Why it's all like this, we will see it later. Okay. But it's not that difficult to understand what happens at start, what happens at the end. But what happens in between is a little tricky. It deals with a lot of math also. Now, you will still be able to do it. એવું કંઈ નથી કે તમને નહીં આવડે. આવડી જ જશે જ્યારે કરાવી. Here. So suppose you close this switch. So the moment you close it, the battery will try to make charge flow. So electrons will start flowing and this capacitor will start storing some charge like that. As the charge will increase, what will happen is that the voltage of capacitor will increase. A point will come where the capacitor voltage and battery voltage will become equal. That's it. Then charging process will not continue. It will stop over there. So at that point what will happen is that even though circuit is completed like this, still current cannot flow. So what happens is just after the closing of the switch, the moment you press this, at that time capacitor is just like an ideal wire to allow current to flow so that it will get charged. Right? But then once it gets charged, it will block it. It will not allow the current to flow. The reason actually is as follows, that electrons come here. હવે બહુ બધા electrons આવી ગયા તો એ વધારે electrons ને આવવા નહીં દે. Make sense? Yes. Yes or no? If there is no electron here and no charge here, no extra electron, no charge anywhere, then new electrons will come and settle here. So charge will build up. Soon a time will come when the battery cannot push the electrons enough. So the charge will stop flowing. Did you get there? The current will stop. So that's what this whole thing is. What happens in between these two? Right? Okay. So this is the basic. What? Just after closing switch, capacitor is ideal conductor. Means it will allow current to flow easily. And after a long time, it will become ideal insulator. Ideal conductor. And પછી ideal insulator, because it has got fully charged, it will not allow charges to flow anymore. Understood? Yes.
T is equal to infinite can be
Long time.
એટલો બધો ટાઈમ લાગશે ફૂલી ચાર્જ
બસ શું ફરક પડ્યો? Basically in theory, listen to this. In theory, a capacitor connected like this takes infinite time to charge. Okay, but in practice we see that in a few milliseconds, in fact even about less than 1 millisecond, it charges almost 100%, almost, not 100%, almost, right? Okay, so in theory it takes infinite time to completely charge the capacitor, but practically you can get to like 99% of the charging within 1 millisecond. પછી બહુ વાર લાગે. The process slows down. Obviously, the more charge there is, do you realize the more repulsion will be? It will not allow more charge to come. એટલે સ્ટાર્ટિંગમાં પ્રોસેસ એકદમ ફાસ્ટ થઈ જાય. પછી ભલે જ નહીં જલ્દી. Did you understand? Right? But yeah, all those details about what happens between zero time and infinite time. Okay? This sentence is clear. So go if this is a 12 volt battery and this is a, let's say, a 4 ohm resistor. Okay, then at starting, how much will be the current? At starting, when you just press the switch and turn it on, how much will be the current? આ તો કઈ કરતું જ નથી. It will allow charge to flow. 12 volt, 4 ohm. કેટલો કરંટ આવે? 3 ampere. Yes or no? આવું આવડે કે નહીં? Clear or not clear? 12 volt, 4 ohm, so 3 ampere. શું કર્યું? Ohm's law. V equal to I. Got it? Yes. Sure? Okay. Fine. Right. So such things are required, but at infinite time this will block the current. So આ વસ્તુનું વેરિએશન હોઈ શકે. For example, 12 volt. Okay. And this is again 4 ohm. Okay. And this is another wire 4 ohm. Another resistor. So at start, when you just press the switch, okay, just close it, on it. What will happen? This capacitor behaves as ideal wire. It will allow current to flow. Current can flow. These are in parallel. Is that okay? Because current, this is not there. It's just allowing it to flow initially. Someone sure? Yes. Absolutely clear. So current will flow through both. These are in parallel. Parallel. Rules so same rules happen. Right? That's why these are in parallel. Got it? Sure. So our equivalent distance so that 4 4 2. 1 by r, 10th formula. 1 by r equal to 1 by r on 1 by r. Okay? So 2. This is 2 ohm and this is 12 volt. So current will be 6 ampere. But after a long time, what will happen? This capacitor which was there will become insulator. Insulator no meaning to current will not flow. એટલે હવે અહીંથી flow જ ન થાય. એટલે આ ખુલ્લું થઈ ગયું. It's called open. Open means contact is broken. Did you understand? Why? Because current cannot flow here. So now, is this resistor going to do anything? It's not even attached. You understand what I said? This resistor is not even attached. So આગળ નાખો તો હવે શું current? 3 ampere. Did you understand? So earlier current was 6 ampere. After capacitor got charged, the current becomes 3 ampere. Okay, our question પૂછી શકે. And what's the current at start? What's the current finally? Etc. etc. Okay, current. What's the current in between? At some time, you will put it. But like I said, we'll keep it for later. Initial and final. Okay. Just after closing the switch means that t equal to 0 and that t tends to infinite. That's our very well. So let's go to question 6. Up to 6.5 we say when we use the career. In adjoining diagram, assuming battery is ideal, condenser C. Condenser means capacitor. Condenser means capacitor. Okay. In the adjoining diagram, capacitor C will be charged to voltage or potential V only if. Okay, if which of these? Right? Okay, so first thing, look at the switches. Right now both are open. Do you see them? Both are open. Open meaning current will not flow or charge cannot flow. Okay, contact nothing. Now first thing is clear. If you want to connect the first the capacitor, it is compulsory to close S1. Yes or no? Yes. So એનો સમજ પડી? If you don't close S1, battery will not get connected to capacitor. Clear?
Yes.
Sure?
Yes.
Okay, S1 તો close જ હશે. Fine? Fine or not?
Yes.
Sure?
Yes.
What if you close S2 or open S2? That's all we have to discuss. So, if you close S2, if you would close S2, right, then S1 is closed, S2 is closed. So, what will happen? The current can flow through 5 and then 10 and then go back to the battery. Yes or no?
Yes.
Sure?
Yes.
Everyone got that? See, I will check your response about this topic, okay? Suppose I see that you all are struggling really, then we can do it after the third chapter. Okay? You understand what I said?
Yes.
જોઈએ એક બે સમ કરી દો બરાબર ફાવે નથી ફાવે ખબર પડી જશે તમને. Okay, so here is the battery, right? Here is a, and here is capacitor, and here is another switch. અહીંયા છે ને કઈ close છે what 10 ohm, and this is 5 ohm, okay, and then it's like this, right? So if you close S1, it will close કરવાની છે, there is no doubt about it. Now if you close this also, then current will flow through this. Is it clear? Sure? Okay, so if I want to find voltage for this capacitor, it's given in question that the voltage should be V. You will like ne? In which case can we have the potential of the capacitor? We can charge the capacitor to V. You like it? Cannot like it?
Yes.
Okay. That means this capacitor should get all the voltage from the battery. Yes or no?
Yes.
Yes or no? Sure? Absolutely sure? Okay. So that means there should be nothing else that takes away the voltage. Correct? Okay. And if current flows, whatever current flows, then voltage is always there for a resistor. Yes or no? Our break no for it. For example, this is let's say 10 volt. And if by chance 1 ampere current flows, okay, then do you realize that this resistor will take 5 volt? Yes or no? You know how to do it. Why 5 volt? V what do I have? 1 5 volt. So this will take 5. Then if you take Kirchhoff loop like this, second rule use karano aam jano. Suppose we start with A B C then go D goes to E. Okay, so if we take A B D E, if we take A B oh sorry A B D A, excuse me. Okay, એવું કઈ જરૂર નથી B થી start કરે. You can start from anywhere, ફરી પાછું જવાનું. It will give you the same value. So if we start from A, first we have to cross from negative to positive, means from low to high. So શું લખું? Plus 10. Did you understand? But yeah. So here you see we are going to cross this resistor. We are going to cross the resistor. When we say resistor has this voltage, it's actually the voltage, the potential difference. Okay or not okay? Okay. Now think about it. Naturally, charge flows. We say current is the flow of positive charge. Positive charge tries to go from high potential to low potential or low potential to high potential. Low to high. Let's see. Suppose there is a positive charge. Okay. અહીંયા એક point છે 0 volt અને અહીંયા છે point 100 volt. Okay. How would the electric field due to the potential be? How would the electric field be? Left to right, right to left. Right to left. Clear or not clear? કેવી રીતે ખબર પડી? High potential to lower potential. આમ આવશે ને? This is the electric field. Yes or no? So આ positive charge કઈ બાજુ જશે? If you put it here, will it go towards higher potential or will it go towards lower potential? Lower potential. Clear or not? એના બદલે electron નું કતો? It will go towards higher potential. Clear? Everyone? So that means on its own, positive charges can flow from higher potential to lower, and negative charges can go from lower to higher. Clear? Acha. So એનો મતલબ current will flow from higher to lower. Yes or no? Because we take current as a flow of positive charge. Correct? If you say electrons flow opposite, they also don't tell. Electrons flow opposite and current flows this way. And conventional current કહેવાય. જો કંઈક કીધું હોય તો. Right? So that's why B is higher and D is lower. I repeat, B is higher and D is lower. So that -5. Then do you realize because current is flowing here, a -5 subtracting. 5 subtracting, isn't it? Yes or no?
Yes.
And then we go for capacitor. This side will be positive, this side will be negative. So it will be minus VC. VC is the voltage of the capacitor. Then that is equal to 0. So VC is VC equal to 10? No. This is equal to 5. So is the given condition in question satisfied? Is the given condition satisfied? Not satisfied. Acha how કેમ થયું? Because this current can flow here, here, here. Current આમ નહીં જાય. Do you realize? આમ ન જાય. Why? Finally, when the capacitor becomes charged, the current will not flow in the capacitor. A sentence શું છે? A charged capacitor will be ideal conductor or ideal insulator? Insulator. Is that okay? Clear or not? So current क्या flow होता है? Will current flow from D to E? No, because there is an insulator. Okay. Question में लिखो जे. We want to charge it to V potential. Means we have to talk about it after charging. How much is the potential? आम तो flow नहीं है because this will behave as an insulator. So where will current go? 1 ampere here and come to it. Did you understand? Yes or no? Sure. So આમાં તો problem નહીં ને. So there is only one way. -5 કેમ આવ્યું? Because V is equal to IR. How can you stop that? -5 નો આવવું જોઈએ ને. 0 આવવું જોઈએ ને. How can you make that 0? By not allowing current to flow. समझ पड़ेगी नहीं? If current will not flow, suppose current flows not, then this minus will not be there, right? Got it?
Yes.
Because if current is 0, then voltage for the resistor, this one, is also 0. Here 0. Got that? Yes or no? Sure. So then here you get the same as this. કારણ કે આ 0 હોય તો આ બે same આવે. Make sense? તો કરંટ 0 કેવી રીતે થાય? આ બંધ કરી દો ને. Did you understand? Turn off that switch. Means open it. So હવે શું થાય? Current will flow like this. પછી ક્યાં જશે? નીચે તો કેપેસિટર જવા નહીં દે. તો ક્યાં જશે? It will not flow. Current should definitely flow in a loop. Yes or no? એ તો ખબર ને પાછું તો આવવું જ જોઈએ. Got it? So if you open this switch, then current cannot flow here. It cannot go there also. It means current will stop. Is that okay? So if S1 is closed but S2 is open, what will happen? Current has no path to flow, and because current has no path to flow, this resistor cannot decrease the voltage, and that's why capacitor will get all the voltage. Did you understand? Or not clear? એવું થાય.